shrinking the multi-millennial problem of global warming down to size by cooling the ocean surface down to the pre-industrial level in 226 years and maintaining it there. The planet has gas problems. Amongst these are fossil fuel emissions, methane emissions from permafrost, lake and ocean seabeds, and ersatz natural gas bridge to a zero-emissions future that in reality is an effort by the industry to shift liability away from itself onto its consumers, and the off-gassing of carbon dioxide from the ocean's surface as it warms. Although the last of these is the problem that least comes to mind, it is the most urgent of the four and the one that will be the most persistent and yet the solution from which the maximum benefits are to be derived. Fossil fuels are the greatest contributor to global climate change, accounting for over 75% of global greenhouse gas emissions and nearly 90% of all carbon dioxide emissions. And these emissions blanket the Earth, trapping the sun's heat, raising the surface temperature. But even if all fossil fuel emissions were to stop today, the Earth's temperature would continue to rise for a few decades as ocean currents bring excess heat stored in the deep ocean back to the surface over the course of 1,500 years. The paper Quantification of Ocean Heat Uptake from Changes in Atmospheric Oxygen and Carbon Dioxide Composition used the measurement of these gases as the oceans warm and releases these gases as a proxy for global warming. They calculated between 1991 to 2016 the average warming amounted to about 409 terawatts a year, about 20 times the energy we consume every year, which is the equivalent to a planetary energy imbalance of about 0.8 watts per square meters of the Earth's surface. They determined about 1.11 parts per million of these gases were going into the atmosphere on account of warming of the tropical ocean's surface each year. And since the ratio of these gases in the atmosphere is 1 part oxygen to 1.05 parts carbon dioxide, about 0.56 parts per million of CO2 is currently going into the atmosphere solely based on the increasing warming of the ocean surface. Since the total increase in atmospheric carbon dioxide concentration every year is about 2 parts per million, about 28% of this is the result of heating rather than new emissions. 1 part per million of atmospheric CO2 is equivalent to 7.81 gigatons of carbon dioxide, and since 2 parts per million is going into the atmosphere each year, about 4.4 gigatons of carbon dioxide is going into the atmosphere as a consequence of accelerating surface warming. $100 per ton is the carbon dioxide removal industry's standard bearing metric. About $600 per ton of CO2 is the current estimated potential for existing technologies. So the release of 4.4 gigatons from the surface due to warming is costing the global gross domestic product about $2.6 trillion annually and needlessly. Scientists predict up to 10 gigatons of carbon dioxide will have to be removed annually from the atmosphere by 2050, with increased removal capacity up to 20 gigatons a year by 2100. Which even at $100 a ton would amount to from $1 trillion to $2 trillion a year, and is a needless expense and consumption of a limited resource and an added burden to a public that is already burdened with oppressive overhead. The oceans hold 60 times more carbon than the atmosphere and absorbs almost 30% of carbon dioxide emissions from human activities. Any removal scheme to remove carbon dioxide from the atmosphere would rapidly come up against the ocean's capacity to rapidly fill the atmospheric carbon dioxide void. In a recent talk with the Healthy Planet Action Coalition, David Keith was asked, is it 40 times or 20 times harder removing carbon dioxide from the ocean rather than the atmosphere? And his response was, very roughly, it's a factor of 2 times more difficult. Presumably, therefore, it will also cost about twice as much as currently anticipated to address the atmospheric carbon dioxide problem. All of which would be moot if the ocean surface was cooled by thermodynamic geoengineering, that would produce twice as much energy as fossil fuels, at half the cost of those fuels. The technical breakthrough that would bring this about is a heat pipe that is the most effective, passive device that employs phase changes of a working fluid to transfer heat from a hot to cold heat sink. Recent research has pointed out hurricanes shift heat deeper into the ocean than originally recognized as well. And weak El Niño events do the same by pushing heat deeper into the thermocline of the eastern Pacific Ocean basin. As was the case in the 1998 to 2013 warming hiatus, but thermodynamic geoengineering would do this 14 times longer than the hiatus and 226 times longer than the few months-long respite provided by hurricanes. And this 226-year respite can be replicated 12 more times by recirculating the heat of global warming. The Healthy Planet Action Coalition has identified 18 potential direct climate cooling methods, but thermodynamic geoengineering is the only one of these that can cost-effectively replace fossil fuels. Even if all fossil fuel emissions were to stop today, the heat that has been trapped in the ocean won't all be released for at least 1,500 years, because that is length of the thermohaline circulation cycle, which can be doubled by 13 to 226-year cycles of thermodynamic geoengineering, which short-circuits the movement of heat from the tropics towards the poles. The very fact warming releases carbon dioxide from the ocean surface to the atmosphere makes carbon dioxide a lagging indicator of global warming, and the temperature increase a self-perpetuating feedback loop that is leading to a climate disaster. In a 2014 Nature article, Climate Policy, Ditch the 2 degrees Celsius warming goal, David Victor and Charles Kennel argued that politically and scientifically, the 2 degrees Celsius goal is wrong-headed. Politically, it has allowed some governments to pretend that they are taking serious action to mitigate global warming, when in reality they have achieved almost nothing, they cautioned. Scientifically, there are better ways to measure the stress that humans are placing on the climate system than the growth of average global surface temperature, which has stalled since 1998 and is poorly coupled to entities that governments and companies can control directly, they said back in 2014, just after the 1998 to 2013 hiatus had ended. This view was widely panned by climate modelers at the time, but the current evidence and concern with the rapid warming of the ocean shows the Victor and Kennel were prescient. A target of 0 degrees of warming from the pre-industrial level is neither ambitious nor unachievable with an ocean heat-focused climate policy. Because as the following graphic produced by Gavin Schmidt for NASA's Goddard Institute for Space Studies Model Earth System Model shows, the vegetation, oceans, ice sheets, and carbon cycle climate feedbacks, which are only beginning to kick in, some of which operate on a multi-millennial scale, will produce a 3 to 6 degrees Celsius Earth system sensitivity. These are singularly addressed by the multi-millennial scale benefits provided by thermodynamic geoengineering. This is because of the transient climate response to carbon dioxide levels in the atmosphere, also known as the Charney sensitivity. When added to the Hadley sensitivity, which includes carbon cycle feedbacks, plus the Hansen sensitivity, which adds ice sheet albedo feedbacks, is combined with the Earth system sensitivity, which includes all feedback dynamics, then the cumulative total anthropogenic carbon dioxide emissions from 1850 indicates 0 degrees of warming is the only acceptable goal, and can only be achieved by converting the heat accumulating in the oceans to work and sequestering the unconverted heat in the cold heat sink of the deep, from where it returns and can be utilized again until all of that heat has been converted and the waste heat of those conversions has been dissipated to space, which is an undertaking that will take about 3 millennia. The oceans are the only place that can store heat in the climate system. Us a favor by grabbing about 90% of our heat, but it's not going to do it forever, says John Abraham, a thermal sciences professor at the University of St. Thomas in St. Paul, Minnesota. To fail to immediately address the total Earth system sensitivity is the ultimate procrastination and false economy, and is a supreme disservice to future generations.